In this Algebra 1 video, we're in Chapter 5, Lesson 5. We're going to talk about solving inequalities that involve absolute value. Our objective is, as the student, I can solve and graph absolute value inequalities. We will do both less than and greater than. Oh, and we'll do or equal to, of course. Because I will apply the definition of absolute value. Now, as a reminder, this is just like in Chapter 2 when we were solving absolute value equations. And as a brief reminder, the definition of absolute value is the absolute value of 5 is 5. The absolute value of negative 5 is still positive 5. In other words, the technical definition is it's the distance from 0. But if it's a distance, it's going to always become positive. So in other words, it's the positive version of the number, even if the number is already positive. That's basically what we're saying. So for each of these questions, we're going to have to use that definition. So as a brief reminder, I just made up this quick little equation on the bottom right. If we were to solve this using the skills we learned back in Chapter 2, what you had to remember is you had to remember to write both versions of it. One where it equals positive 8 and one where it equals negative 8. So you didn't need to write down this example, but just as an example, you'd have two answers to that equation I just made up. X equals 2 and x equals negative 6. Alright, so now let's take the same concept but apply it to inequalities. Okay, so first jot down some of these notes. In general, how to solve absolute value inequalities is you have to do what I just said. You have to set up both cases. One, where it's a positive number on the right side, or on the other side, whatever, outside the inequality. And two, where it's negative. But there's a special thing. When you make it the negative version, you have to flip the inequality sign. And I'll slightly explain why in just a minute, but we'll get to that. So get those written down. Okay, in general, when you're graphing, when you're graphing absolute value inequalities, if it says the absolute value of whatever is less than, I don't know, 5, if it says less than, okay, it's almost always going to graph like this. It's going to be stuck in between. You're going to have a minimum value and a greater value. Now, technically, there is a no solutions option, and the no solutions option is one where it's asking you to do something that's not possible, and we'll get to that. Now, for the other one, oh, by the way, and the key to less than absolute value inequalities is it's all about where they overlap. Just like when we're solving and inequalities, compound inequalities, it's going to be just like that. It's where they overlap. So I'm calling it and-ish. And in fact, that's the format we're going to write our answers in. So let's say this was 2, let's say this was 6, I'm just making this up. The answer would be 2 is less than x, which is less than 6. That's how we would write our answer. You could also write your answer as x is greater than 2, x is less than 6, which would still combine to give you that compound inequality. So the answers we're going to write that way. Now, if it's a greater than absolute value inequality, it's generally going to look like an or compound inequality, to where we're going to have two of them going away from each other. Now, it is possible to have all real numbers here, just like when we talked about back in compound inequalities in the last section. You can have a situation here where it's all real numbers, and we will do an example of that, and I'll show you what I mean. But for now, let's go ahead and just think of it as it has a lot of characteristics. As far as graphing it looks like an or compound inequality. Let's do some examples. Okay, we're going to solve and graph this absolute value inequality. So write this down. Okay, so when solving this, let's follow the rules that we were given. We set up both cases. One where it's positive, so we just write what it says. And since that's a 7, so you don't know it's not an inequality, we'll put a line through it. So we write 1 the way it looks without the absolute value bars. But then we got to write it down once with the negative 2 over there. And that special rule activates because I just changed the sign. It becomes greater than or equal to. Now, to help you understand why, some people are like, well, why do you have to flip? As a quick experiment, pretend you had this. We had less than or equal to, let's see, less than or equal to, but we said we had to consider the negative version. So technically there's a negative sign right there. Well, to solve this, the easiest way is to get rid of that negative now. Pretend it's like a negative 1 if you need to. So you'll divide both sides by negative 1. Well, if you divide both sides by negative 1, let's see what happens. You get n minus 7, and then that becomes a greater than or equal to, and then the right side is just positive 2. Okay? Nope, I'm sorry. I combined two steps there at once. That's positive 2 right now. We're saying, what if we didn't change it? And now it becomes negative 2. There we go. So this, as an experiment, it still becomes what we just said. So if you would like to save time, you can go straight to this step. So I'm going to erase that and just write it originally. Alright, so now solve both of these and you are ready to go, and those will be your answers. You know how to solve these one-step inequalities. Okay, so solve both of them and you've got your answers. Now I want you to go ahead and graph your answers on a number line. Draw out your number line. That took me about 6 seconds to draw, but now graph it accurately. So we know that it's less than or equal to 9. Okay, so 9 is right here, or equal to means filled in circle. So less than is to the left. We know the other one is greater than or equal to 5, so go to 5, filled in circle. This is greater than or equal to, so that's everything to the right. So it's all about where they overlap. It's kind of just like an and compound inequality, like in that regard. Less than ones are that way. So because it's all about where they overlap, we don't need what's outside of here. Okay, so we're only concerned with the inside. So that's the graph of your answer. Now, as a final thought, because I told you to get in the habit of it, we're going to write our answers in the form of a compound inequality, meaning I want you to write it like this. N is going to be stuck in the middle. We know it's bigger than 5, so we can say alligator eating the N because it's bigger than 5 and put a 5 right here. So that means N is bigger than 5. But it's also smaller than 9, so like this. So this is the full, complete answer. To write it out as an inequality, but then you can also graph it as well. Write this down. Let's do another example. Okay, write this example down. We're going to knock this one out. Okay, start by writing the two cases of it. The first one is just the one that is what it looks like. But for the second one, we're going to make this negative, and then we're going to have to flip that sign for the second one. Okay, so now take a moment to solve both of these. They both start off the same way. Subtract 2.5 from both sides. So they both start off the same way. Now finish them from there. Okay, so these are our two answers. Now go ahead and write them together at the same time. So if x is less than -1, x is greater than -4. That means -4 is the lower limit and -1 is the upper limit. So we can write it in this format. -4 is less than x. Notice the alligator is eating the x when the alligator was eating the x down here. He was still eating the x. Those are my teeth. And that is going to be less than -1. Okay, so that's the way to write this as a compound inequality. But now, let's go ahead and graph our results. Okay, sketch out a number line. Now let's graph these results. Let's see. It says x is less than -1. It's an open circle because it's not or equal to, and that's going to the left. Then it says x is greater than -4, so open circle going to the right. Now, the only thing we're concerned about though is where they overlap. So we don't need what's out there on the outside. I'm going to erase what's sticking out over here, and we're going to just shade what's in between. So it's just what's in between with empty circles. And that's the graphic version of this question. Now you, give this one a shot. Hit pause and try this one. Alright, so we're going to start by setting them up with the positive version and the negative version. Okay, set up both versions. Remember to flip it when you do the opposite sign version. As a side note, if this had already been -5, this would have been -5, and then when we made this +5 over here, we still would have flipped the inequality the same way. If you change the sign of what's out there, you flip the inequality. Alright, now solve both these. Alright, so you've got your two solutions, your two boundaries. So now write those as the compound inequality. And it turns into that when you write those together. I'm putting little lines in my 7 so you know for sure that those aren't inequality signs. Alright, let's graph the result. Alright, let's get those graphed down. Okay, and that's a graphical version of your answer. Make sure you have this, and let's move on. Okay, now we're going to go ahead and give this one a shot, and I'll give you a warning. This one, one of your answers will be a fraction. Hit pause and give it a shot. Write both versions, now solve them both. They start out the same way, and they both have the same last step. Those have different answers. Divide both sides by 5. Okay, for the one on the left, we have 9 divided by 5. 9 divided by 5 is an improper fraction, so it simplifies to a mixed number of 1 4/5, or 1.8. So y is less than or equal to 1.8 or 1 4/5. Now for our one on the right, we get y is greater than or equal to -1. So let's graph those results, but before I do, I'm going to write them as a compound answer. This is how you write your answer as a compound inequality. Okay, now let's graph it. Alright, I got my number lines, now let's graph our results. So it told us greater than or equal to -1, so that's a closed circle. It's going to be going to the right. And then it says less than or equal to 1 4/5. Well, 1 4/5, that's between 1 and 2, but it's just closer to 2. So estimate it's going to be about right there, and that one is less than, so it goes this way. So that is the graph of your answer. I want to do an example with you where the answer is no solution. We can do this a lot, and we can do this logically. Take a look at this example. Write it down for a moment. Okay, so this question says the absolute value of y plus 3 is less than -1. Think about that to yourself for a moment. Meaning, if you were to say whatever is in here, doesn't matter what's in here, if you take the absolute value of something is always a positive number. But look, they're saying it's less than -1. Less than -1 means it's a negative number. So they're saying the absolute value of whatever is in here will be a negative number. But that's impossible. The absolute value of a number will never be negative. So this question has no solution. Even if it had said less than 0 still means negative numbers. Even if it said less than -8, less than -8 still negative numbers. So you cannot have the absolute value of something equal to a negative number. So the answer to this question is simply you have no work to do. The answer to this question is simply no solution. So you would write no solution, or you could use that symbol for an empty set, meaning the solution set is empty. And it's just kind of like a 0 with a slash through it. And so you can put that little braces, brackets, I always get them backwards, whatever they're called. You can put them in there. So it has no solution. I wanted you to see that. So less than, you notice we kept avoiding anything where it was less than a negative. It's because it's not possible. Okay, so now we're going to do some greater than absolute value examples. And for each of these, I'm already going to give you a heads up. They're going to have a lot of or-ish compound inequality characteristics. So do the same thing here. Write both versions, the positive and negative, but for the one where you change the sign, you're going to have to flip the inequality just like before. And as a note, if this was already a negative number here, then when you change your sign, it becomes positive, so you would have less than +6 as your second one. All right, let's set this up. Okay, so here are both yours that you're gonna solve. Now you already know how to solve these at this point, so go ahead and just get those solved. Okay, so for this one, you do not put these together as a compound inequality. You would literally just say your answer is this or that. So those are your two answers. So this is one where they're going to be heading away from each other. So let's go ahead and graph this result. Okay, so get your number line out there and now graph your results. Less than -4, that means open circle, shading to the left. Greater than 8, that means open circle, shading to the right. Now feel free to go by 2s if you felt your number line was going to be too long, not a big deal. I just went by 1s, not that big. It takes an extra moment to draw. But okay, this is your graphic example of this question. Okay, so this is an example of a greater than absolute value inequality. Make sure you write all this down. Okay, this is going to be a special case. In my special case, I don't want to give it away if it's no solution of all real numbers. I want to show it to you first. So let's go ahead and set it up. Press pause and set up the way you know to set it up. Now solve both of them. Okay, once you solve both of them, now even if you still don't quite see it, let's go ahead and graph it. Then you'll really be able to tell. Alright, so we have greater than 4, so that's an open circle going to the right. We have less than 8, so that's an open circle going to the left. But remember, I told you, these are like ors. Okay, it does not matter if it's where they overlap. So these keep going. So this one keeps going that way. This one keeps going that way. So you'll notice they cover all numbers. So the answer to this question is all real numbers. So all real numbers. So it's just like an OR inequality where they kind of go through each other. So the answer to this question is all real numbers. So write this down. And as a heads up, this is what's always going to happen when you have greater than a negative number. I believe this is always going to happen in these cases. So yes, anytime it has greater than a negative number out here, it's gonna be a OR inequality, compound inequality pretty much, and they're going to be going across each other. So yes, it's going to be all real numbers. Alright guys, so we've now done an example of, quick recap, we talked about how to solve, we did some examples of less than, spent more time on these since it's the first one and it's the main one, and then it's almost always going to be stuck in between. I even showed you an example where it was going to be no solution because the absolute value of anything will never be a negative number. So by the way, the difference between that and what we just had right here was this says greater than -2. I agree that what's in here is not going to be able to equal -1. I agree with you there. But it can equal 0. The absolute value of 0, if all that was 0, can equal 0. So that would be allowed. And it can equal 1, 2, 3, 4, 5, 6, 7, 8. It can equal positive numbers. But I agree with you that it can't be -1. But because it does have some possibilities that are greater than -2 that it can be, that's why we actually pursue it. Whereas the difference was on this one, it says less than -1. It's saying only negative numbers. It's saying y plus 3 can only be less than -1. It'll only be a negative number. We already said the absolute value will never be a negative number. So that's why this one is no solution, whereas this one we actually pursued because it did have some solutions. All right, just make sure you have these written down. Come to class prepared, and we'll go a little bit further. In class, we'll also remind you how to graph these. If you're given the graph, how to write the equations, or vice versa. And it's going to use the same similar skills we talked about when we were graphing our solutions to absolute value equations. It's going to be very, very similar. But we're going to do absolute value inequalities. All right, take care, guys.